Here's a quick intro to exponential functions and graphing them. First of all, let's look at the parent function. F of x equals b to the x. Now there are actually many parent functions, as b, which is a constant, will yield different values based on whether it's greater than 1, between 0 and 1. There's certain things about b that we just don't do in this class. B is called the base. B is any number such that b is more than 0 and not equal to 1. If b is small, and by small I mean between 0 and 1, it will be a decreasing function. If b is large, meaning that b is more than 1, it'll be an increasing function. X can be any real number, making the domain all real numbers. Now let's take a look at graphing the parent function. We're going to do our graph with x values between -2 and 3. And since our parent function for this example is 3 to the x, we'll be doing 3 to the -2, which is 1 over 9. Remember that negative exponents flip it, so it's like 1/3 squared. 3 to the -1, 1/3. 3 to the 0, anything to the 0 is 1. 3 to the 1 is 3, 3 squared is 9, and 3 cubed is 27. Let's see what this looks like on the graph. So here we've plotted our points, and now we just need to connect the dots. Now the main characteristic of looking at the exponential function is that as you go to the left, you see that it tapers off to a horizontal asymptote, and as it goes to the right, it explodes up. My domain, as mentioned before, is -infinity to +infinity, otherwise known as all real numbers. My range, as you can see from this, is from 0 to infinity. My x-intercept, there is no x-intercept for the parent function. My y-intercept is 1. Do I have any asymptotes? Yes, I do. I have a horizontal asymptote at y equals 0. Now, if you look at this graph, do you think it's increasing or decreasing? Remember, we read graphs like a book from left to right. As I go from left to right, it is going up always, from -infinity to +infinity. This is also never decreasing. So now we're going to use function transformations to graph. We're going to give the domain and range, and we're going to write an equation of the horizontal asymptote. Before we do that, let's take a quick review of transformations. All our horizontal transformations occur inside the function, and all of our vertical transformations occur outside of the function. The thing that's multiplying the parent function will stretch it, and the things that are adding or subtracting from the parent function will shift it. Hence, A is a vertical stretch or compression, B is a horizontal stretch or compression, C is a horizontal shift, and D is a vertical shift. Feel free to pause and take notes as you need to. Now, when we look at this for a exponential function, you'll notice that all the horizontal transformations are in the exponent of the function. So let's get back to our function. here we have our original function, 2 to the x. Now if we add 1 to each of these, that basically is our transformation. It is a vertical shift up. You're just adding 1 to the y. So that's the original. And there's your shift up 1. Now you'll notice that our new horizontal asymptote is at y equals 1 because the shift was up 1. Here we have 3 to the x minus 2. Now here we have a horizontal shift. You'll notice that each of the values can be seen 2 units above. So the 3 that's at 3 was at 1. Here's how it works. If my x is -1, x minus 2 is -3, so now I'm doing 3 to the -3, which is 1 over 27. When x is 0, I'm doing 0 minus 2, which is 3 to the -2, which is why I get 1 over 9, and so on and so forth. What does this do to my graph? It shifts it over to the right 2. Here we're going to transform 1/3 x to the plus 1 minus 2. What you'll see here is that 1/3 x is 27, but if I'm adding 1 to that, that exponent becomes -2. So 1/3 to the -2 is 9, because remember, negative exponents flip it, so it's like having 3 squared. Now the minus 2 will subtract 2 from the 9 to make it 7. We do this with every point, and you end up with a shift to the left 1 unit and a shift down 2 units. We go left, and then we go down. Our new asymptote, or horizontal asymptote, is now going to be y to the -2. You'll notice that the equation of the horizontal asymptote is always whatever your vertical shift is. If you have no vertical shift, it's y equals 0. And that concludes our video for graphing exponential functions.